Alright, so now we know that we have acceleration to describe physics law. We can come up with one physics law that is truly legit, that is actually a physics law. That physics law is that when I throw something and the thing is flying without being dragged by air or whatever, then we call that thing free floating. And when a stuff is free floating near the surface of the air, it can do something like this. You can do something like this. Those two motions looks different, but I claim that they obey the same physics law, called the acceleration in the y direction is a constant called negative g is going down. That's why you can see the y velocity start as positive and then turn into negative. And I claim that even though one is flying up, one is flying to the side, they are just described by the same physics law, called their y acceleration should be negative g. Okay? This is a frame-dependent description. In all the frame, the ay of the thing is the same, and g is just a constant, so this law works for anyone, anywhere, any place, anytime. Yeah. Okay? And also, x is 0. So if your object is described by this law, we call it projectile motion. So this is one thing you need to know. I don't think it takes too much to memorize it. Projectile motion means you have constant acceleration downward. And that's true for projectile. You just throw something, that's projectile. So now we can try to use physics law to predict motion for the first time. It's the second lecture. Oh, no, not too bad. Okay. Summary session is really fast, you know. Lecture 2, then we're doing physics. Not surprising. So let's say you are putting your frame at where you're going to store your stuff. The stuff is at here, and then you store it with some initial speed called v naught, and the direction you throw it make an angle theta with the horizontal line. That's pretty much all you can describe about throwing a stuff. You just throw it with some speed and at some angle. The direction doesn't really matter because we can just point our x to wherever we're throwing. Okay? And the thing will go like this. And let's try to use physics law to predict its motion. First of all, we learned that the x acceleration affects x velocity, affects x position. It has nothing to do with y. Similarly, y acceleration affects y velocity, affects y position. It has nothing to do with x. So, if the x acceleration is 0, the x velocity must be a constant value. It's not going to change. When the ball is flying here, it has a x velocity. When the ball is flying at here, the x velocity will be the same over here and the same in the beginning. Because the acceleration is only in the y direction, the x velocity at each point will always be the same. It just keeps moving to the right. So if you are just looking at the motion along the x direction, if you only care about how the x position of this projectile change, it's simple. It's just a constant velocity motion. Okay? That's what we can know from this. Second of all, this angle theta and this initial x velocity and the initial speed can be related with trigonometry. You guys know that? Okay? Right now, I'm looking at the triangle with hypotenuse V naught and adjacent side V naught x. This is the initial x velocity, right? If a thing is moving in this direction with V naught, then the horizontal component will be the initial x velocity. And this is what we define as theta. We learned that the definition of cosine is adjacent side divided by the hypotenuse. So the more common way we apply it in physics is to express the component as the speed times cosine. What I did is multiply cosine with V naught, so V naught x is V naught cosine. Does that make sense? So if I want to describe the initial y velocity, what should this be?
Sine.
Good. Good job, Olivia, you're a good student. Good, so this is how you are going to use trigonometry a lot in physics. Usually, you will know the hypotenuse, and then you need to have a quick reaction that the opposite side is sine times hypotenuse, and the adjacent side is hypotenuse times cosine. Okay? Good, so we can now express, all right, let's just keep it as is. And we have that for further purpose. Now, because the acceleration is a constant, so we can apply the constant acceleration motion for y. The y displacement will be the initial y velocity plus 1/2 AYT squared. You don't need to memorize it. Again, if I want you to do anything about it, I will just give it to you on the exam. Okay? But you do need to know how to apply it. Alright, you'll see it later. So, because right now the y acceleration is a constant, so we can use this formula. We just divide for constant acceleration motion. And we can set the initial y to be 0. So that delta y is just the y position of the particle. It starts at 0. So there's no initial y position. V naught y is V naught sine theta. So I can write as V naught sine theta. There's time. And the y acceleration is minus g. So I get minus g times 1/2 t squared. That is how the y position of this projectile will change. It's going to go up and then go down. So the first term will grow with t and maybe go up. But as t becomes bigger, the second term is negative, so it will go down again. Okay? Any questions so far? Now, can someone guess the easier one, the x position as a function of time? It should be similar to this. The initial x velocity will be V naught times what?
Cosine.
Good, cosine, because we are looking at V naught x. And similarly, it needs to be happening at time t. But there's no acceleration in x direction, so we don't need the second term, and that's it. Okay? So, first of all, we apply the result we get for constant acceleration motion and predict that if my physics law says the acceleration is just ay equals minus g, then the y position and x position in this specific frame should look like this. I can stand at somewhere outside that's not on the origin, and the x and y position will be shifted a little bit, but I can just go back and start from my fundamental physics law. Okay? So, the first thing we want to ask is how tall can it reach? The maximum height of y. It might be interesting if you are trying to throw something outward. So, how do you throw something high and tall? You are trying to find how will this value have a maximum. And the way you do that is by completing the square. Do you guys know the term quadratic formula? So if I want to complete a square, I want to write that thing as a big stuff square plus a number with no t. So t will change this parenthesis, but this thing is squared. So if this thing is 0, the thing has a minimum or maximum value. Let me just do it. T squared has minus 1g, minus half g. So I take it out. Then you're left with t squared. You want the cross term to be this. So first of all, there's a minus sign because this is plus, this is minus. So there will be a relative minus sign. I know by dimensional analysis, this thing should be a time. So it should be velocity divided by g, which now we can know that y it should have dimension of length divided by time squared, because g is a acceleration. So it should have a dimension of acceleration, which is defined by some change of velocity divided by a change of time. So velocity is length divided by time. Time is time. So acceleration should have dimension of length times t to the minus 2. You can derive it right away. You don't need to memorize it at all. I think so. You do need to know how to derive this. Any question or